Welcome back. This is Chapter 5, Section 6, Part 3 of the notes. We were finishing the checkpoint at the bottom of page 1. We had finally figured out that -2 is one of the zeros. Use synthetic substitution. It ended with 0 at the end. That made us happy. And we were also able to use the information from the bottom of the synthetic substitution to write the polynomial factored a little bit. Now we're going to finish up here. Excuse the arrow as I move over to the side. We know it's x plus 2. X squared plus x minus 12. Great. Now, we do need to remember how to factor quadratics. But this one shouldn't be too bad. This is x plus 4, x minus 3. It's a little cramped there, I'm afraid. Sorry. But from that, we know x equals -2, -4, and 3. These are the answers we get from each of the factors. And that is the answer, finally, to the first checkpoint on these notes. So let's go ahead and start example 2, which is at the top of the second page. Example 2 is really important because we have a constant term of 3, and I'm going to go ahead and right below it, because I have some space here, write the factors of 3, 1 and 3. Not very exciting factors, certainly. But the leading coefficient is 8. Now that makes it a little more interesting. I've got a little bit of space over here. That factors are 1, 2, 4, and 8. You've done a couple examples with rational zero theorem, but this is the first time where the leading coefficient makes it interesting. Here's what I'm talking about. First of all, 1 over 1 and 3 over 1 are definite possible zeros, and of course positive and negative versions of each of them. But that 1 and 3, factors of 3, need to be repeated for each of those factors of 8. So it's 1 over 2 and 3 over 2. Excuse me. Positive and negative. Positive and negative. And it's 1 over 4, yes, and 3 over 4. Again, positive and negative. Positive and negative. And it's 1 over 8 and 3 over 8. Positive and negative for each of them, just as always before. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different things to work with. It's kind of a lot. Now, on your assignment, I crossed off this part, choose the reasonable values using the functions graph. And the reason why is because we don't all have graphing calculators. So if you have a graphing calculator, you might be able to notice that none of the numbers could possibly be more than 1, so you wouldn't do 3 or something like that. It depends on what you see. But you might not. Now, the book very kindly this time tells you that -3/2 works, so we're going to go ahead and do this pretty quickly here. We have 8, excuse me. Okay, so we have 8 times -3/2 is -12. Adding up makes -10 times -3/2 is 15. Adding up is -6. Times -3/2 is 9, adding up is 2, times -3/2 is -3, adding up is 0. Happiness? It's supposed to work. That means that -3/2 is a 0. That also means we can factor it, but that's more complicated. I'm going to save that for the next video. So please join me there.